All right, this is my presentation on ACTN3. So my goals for this presentation are that by the end, you better understand the gene and you're able to tell me why ACTN3 is known as the speed gene. So I chose this gene because I thought it was interesting and I wanted to find out more about how it affects your athletic abilities. So, about 20 to 30% of people worldwide have this mutant gene, and its gene product is alpha actin binding protein. It's expressed only in type 2 muscle fibers like skeletal muscles. Over here, I have a graph to show you how skeletal muscles has a high presence of this mutant gene. So, a little more about ACTN3 is that it's the structural component of sarcomeric Z lines. Proteins drive muscle contractions and relaxation, and sarcomeric Z lines anchor the sites for actin based thin filaments. And over here, there is a demonstration of that in the bicep muscle. So where is ACTN3? It's found in humans. The size is about 16,940 base pairs, and it's located on 11q13.2. So it's located right here at region 13.2 on chromosome 11. So transmission and associated diseases. This is an inherited disease. It is a nonsense mutation in the X chromosome. It happens when the cytosine changes to a thymine, and this results in a premature stop codon. So diseases like ACTN3 deficiency happen because of this premature stop when it's not being synthesized anymore. So for alleles, the most important one is R577X. When this gene is allelic polymorphism, it can impact exercise recovery, injury risk, and training adaptations. And speed and power are associated phenotypes with this allele. And elite athletes tend to have high frequencies of this R allele. So for example, if you didn't have this allele, then you have increased post-exercise muscle damage following eccentric training. But if you have the allele, then you have reduced post-exercise muscle damage following an eccentric training. And these are my references.